We've done complex rational expressions before. The biggest difference today is going to be there will be more x's in the denominator. So we're going to use what you've learned about adding and subtracting rational fractions, and we're going to do more of that type of thing in the context of a complex fraction. So it should be really familiar to you. So Roman numeral 1 are your steps. And this should look very, very familiar. You're going to simplify the top and bottom. And this might involve factoring, depending on what you're doing. So simplify the top and the bottom. And then number 2, you're going to eliminate the bottom with its reciprocal. And then the important part to remember, you're going to eliminate the bottom with its reciprocal, and you're going to multiply the top by the same fraction. So you use the same fraction, top and bottom. So now you should have eliminated the bottom of the fraction, and you have a bunch of things being multiplied together. So your third step is just to factor and simplify. Okay, so here's a few suggestions, math tips for you when doing these problems that I find help students do the problems easier and not get lost in the process. The first thing I'd suggest is to make the fraction bar heavy, like the main fraction bar. Make it really heavy so it's obvious where the big middle is, because you're going to have fraction bars on the top and the bottom. We want the big middle one to stand out. So make that one extra heavy. You need to write ones in the denominators of whole numbers. Much of what we're doing in this section is adding and subtracting fractions. So when you have whole numbers, it's helpful if you put a 1 underneath of it, so it pushes the top up so the numerators line up and the denominators line up. This last one I highly, highly recommend. When you're going to do your multipliers, write your, and I'm just going to call it multipliers, write your multipliers in n over n form. Never get into the habit of just writing a top or a bottom, because that makes your brain think that that's okay to do. And when you're simplifying, it's never okay to just randomly multiply something by a number. You've got to multiply it by a number over itself, because of course, n over n equals 1, and you can always multiply by a 1. Okay, so let's do some examples. Start with example 1. 3 over x minus 4 all over 1 over x minus 4 plus 3 over x plus 1. Okay, so first thing you want to do is simplify the top and the bottom. Now the top is already simplified and I can't factor it. So actually the top on this one is done. It's the bottom. The bottom needs to be worked with, and you can go downwards or sideways. I typically go downwards because you don't really know how long the problem's going to be, and that way you can kind of work down your paper. So on the bottom, we have two fractions that need to be added together. This is something you've already done. So to add fractions, you need a common denominator. So factor the bottoms, and those two bottoms are already factored. They are binomials. You can't divide anything out. And they're not a squared minus b squared pattern. So those are totally done, but I need the bottoms to match. So my first fraction needs an x plus 1. So I'm going to multiply by x plus 1 over x plus 1. My second fraction needs an x minus 4. So I'm going to multiply by x minus 4 over x minus 4. Now that the bottoms match, I can add the tops over one bottom. So let's just recopy the top, 3 over x minus 4 all over, and then I'm going to put the tops together. So I have x plus 1, and then let's go ahead and distribute this 3, plus 3x minus 12, all over one bottom, x plus 1, x minus 4. Okay, so now we're going to finish simplifying the bottom. So just rewrite the top. And 3x plus x is 4x, and 1 minus 12 is negative 11. All over x plus 1, x minus 4. And that top does not factor anymore, so I'm done. So really, this is just combining two things you guys have already learned. You've learned how to add, and you've learned how to factor and reduce. So now we're on the elimination step. So we're going to multiply the bottom by its reciprocal, which is x plus 1, x minus 4 over 4x minus 11. That's its reciprocal. And that means you have to multiply the top by the same thing, x plus 1, x minus 4 over 4x minus 11. So when you multiply the bottom by its reciprocal, factors top and bottom divide to 1. So x plus 1 goes into x plus 1, x minus 4 goes into x minus 4, 4x minus 11 goes into 4x minus 11, and the entire bottom of the fraction is now a 1, which means we can disregard it because anything over 1 is itself. Now on the top, there's an x minus 4 on the bottom and an x minus 4 on the top. We can cancel those out. And that's all that cancels. So what we end up with is a 3 times x plus 1 over 4x minus 11. And that would be your answer. Any questions about that one? All right, let's do another example. Okay, in this one we have 2 over x minus 1 all over 4 over x minus 1 plus 1 over x. Okay, so first step, simplify the top, simplify the bottom. Just like the last one, this one, the top is already simplified. 2 is prime, and x minus 1 is a non-reducible binomial. So the top's done. The bottom, though, we need a common denominator. So remember that x minus 1 is a binomial, x is a monomial, and they're not the same thing. So to make the bottoms match, I need to multiply the left one by the monomial, x over x, and I need to multiply the right one by the binomial, x minus 1 over x minus 1. Now that the bottoms match, we can add the fractions over one bottom. So 2 over x minus 1 all over, and I'm going to combine the tops. I have a 4x plus x minus 1 all over x times x minus 1. Thank you. All right, so we got to simplify a little bit more on the bottom. So recopy the top, 2 over x minus 1. On the bottom, we have a 5x minus 1 over x times x minus 1. And nothing else factors or simplifies, so we are done simplifying the top and the bottom. Now we're going to do the elimination step. Multiply the bottom by its reciprocal. So times x, x minus 1 over 5x minus 1. Multiply the top by the same thing. X, x minus 1 over 5x minus 1. On the bottom, x's divide out, x minus 1's divide out, 5x minus 1's divide out. The entire bottom is now equal to 1. We can disregard it. On the top, I have an x minus 1 factor, top and bottom, that will get canceled out. And so we end up with 2x over 5x minus 1. So don't forget that a monomial x and a binomial x minus 1 are not the same thing. You have to treat them as separate entities. All right, last one. This one, to a certain extent, is easier than the other two, but sometimes they're so easy they're difficult. So this one is 2x over 3 minus 2 all over 1 plus 12 over x. So this is one where you've got whole numbers mixed with fractions. So what you're going to want to do is put the whole numbers over a 1, because that way they line up top and bottom with the fractions. Now on this one, I do need to put the tops together. So to subtract those, I need a common denominator. So if I multiply the second fraction by 3 over 3, the bottoms will match. On the bottom, I need the same thing. I need a common denominator. So multiply by x over x so that the bottoms match. So what have I got now? We put the tops over 1 bottom. So I have 2x minus 6 over 3 all over x plus 12 over x. Okay, so here's where if you can factor, you need to, just in case something cancels. So this binomial here, you can divide a 2 out of. So I have a 2 times x minus 3 over a 3 all over x plus 12 over an x. And I can't cancel anything out even when it's factored. So let's eliminate the bottom. Multiply the bottom by its reciprocal, x over x plus 12. Multiply the top by the same thing, x over x plus 12. The entire bottom divides to 1. And on the top, we have a lot of stuff floating around, but none of it cancels. There's nothing that's the same. So when you put it together, push your monomials to the front and multiply. So your 2x is now at the front, and then x minus 3 on the bottom. The 3 is already at the front, and then you have an x plus 12. And that is as far as it goes. Are there any questions?